A new wanderer from beyond the stars has just crossed into our solar system, and it is unlike any cosmic visitor humanity has ever tracked before. Its name is 3I Atlas. The third confirmed interstellar object, discovered on July 1st, 2025. At first glance, it may sound like just another icy traveler, but what scientists saw in its first weeks left even seasoned astronomers astonished. At its heart, the nucleus is tiny, less than a kilometer across, perhaps no more than a few hundred meters. Yet around that small core hangs a colossal halo of gas and dust, a coma so immense it stretches to nearly twice the diameter of Earth. Most comets in our own system produce faint, dusty veils. This one has unleashed a storm of carbon dioxide so vast that telescopes on Earth and in orbit are straining to measure its limits. Even more unusual, the orbit of 3I Atlas runs almost perfectly along the same flat plane as the planets. Instead of plunging in steeply from above or below, as nearly all comets do, this visitor is sliding directly through the planetary lane, only about 5 degrees tilted from the ecliptic. That geometry means something extraordinary. This object will remain embedded in the very heart of the Sun's electromagnetic environment for weeks, not days. Its interactions will be deeper, longer, and stranger than anything seen from a body that came to us from another star. The discovery itself played out like a modern astronomical thriller. On July 1st, the Atlas Survey Telescope in Chile picked up a faint speck moving against the star field. At first, it looked like a routine comet candidate. But its motion was too steady, its track too fast, and its direction too clean. Orbit calculators quickly flagged the anomaly. Slack messages flew through the Atlas team, then emails across continents. Within hours, astronomers were pulling old sky images, finding the object had already been captured faintly in mid-June exposures. With each new data point, the orbital fit grew clearer. This was no local comet. The speeds were too high, the path unmistakably hyperbolic. By the next day, the Minor Planet Center issued the confirmation. Humanity had detected its third confirmed interstellar visitor. That name, 3I Atlas, breaks down simply. The third interstellar object, I, spotted and caught by Atlas. The number itself is historic. Only 2 such objects had ever been confirmed before. In 2017, the enigmatic ʻOumuamua tumbled through, sparking wild debates over its shape, nature, and even artificial origin. 2 years later, in 2019, the hyperactive comet Borisov screamed past, leaving behind no mystery about its natural origins but raising tantalizing questions about the diversity of other star systems. To catch even one of these is like winning a cosmic lottery. To have seen 3 within a single decade is not luck. It is a revolution in skywatching. Atlas, Pan-STARRS, and soon the Vera Rubin Observatory are finally sensitive enough to catch what has always been there. Fast-moving messengers from other suns, hidden in plain sight until our telescopes became sharp enough to notice. Inside the Atlas control room on that July night, the excitement was palpable. For telescope operators, most nights mean routine surveys. Scan, process, repeat. But the speed of this new object was impossible to ignore. Roughly 60 kilometers per second relative to the Sun, far too fast to be bound by gravity alone. Within 2 days, the world's observatories pivoted. What had been another dot among millions was suddenly the center of attention. Every hour mattered, because every hour the object drew closer to the inner system, and every hour brought new data to refine its orbit. The path of 3I Atlas is what truly sets it apart. Most comets slice through the solar system at steep angles, diving in like arrows before vanishing back to the void. This one instead skims along the same roadway as Earth, Mars, and Jupiter. For weeks it will share the crowded highway of the ecliptic, threading itself between planets, solar wind streams, and the great undulating magnetic sheet that envelops the Sun. That environment, known as the heliospheric current sheet, is a turbulent ocean of magnetic polarity flips, plasma flows, and coronal mass ejections. To embed a giant carbon dioxide shroud into that mix is to create a natural experiment of staggering scale. Hubble and Gemini images quickly confirmed what the first reports hinted. The nucleus is tiny, smaller than many asteroids cataloged routinely, but the coma is breathtaking. Hundreds of thousands of kilometers across, with a chemical fingerprint dominated by carbon dioxide gas, a composition far rarer than water-rich comets we are used to. This alien chemistry offers clues about the system it came from, perhaps a colder nursery rich in CO2 ice, or a star-forming region where volatile compounds freeze differently than in our Kuiper belt. Whatever its birthplace, 3I Atlas carries with it the story of another world's chemistry, written into its vapor. As it moves closer to the sun, the coma will not remain a simple cloud. Sunlight and solar wind particles strip molecules from the nucleus, ionize them, and whip them into a plasma. Mixed with fine dust, the result is what physicists call a dusty plasma. Far from featureless, dusty plasmas are known to self-organize. In laboratory chambers on Earth, they form filaments, waves, and crystalline lattices in mere seconds. In space, the scales are vastly greater, thousands of kilometers instead of millimeters, shifting patterns instead of every pulse of the solar wind. The geometry matters. Because its orbit hugs the ecliptic, 3I Atlas will spend weeks immersed in the heliospheric current sheet. This is the place where the sun's magnetic field reverses direction, warping into a great wavy plane that spirals outward across billions of kilometers. Ordinary comets dart across it quickly. This one will bathe in it. Past comets have had their tails literally torn away by coronal mass ejections, giant eruptions of charged plasma. Astronomers have watched these disconnection events unfold dramatically, the comet's luminous tail severed in hours. With 3I Atlas's unusual chemistry and massive scale, such events could be spectacular. Bright outbursts, sudden shifts, or even multiple tail fragmentations as it weaves through storm after storm. October 2025 is when the real drama begins. On October 1st, the interstellar object sweeps close by Mars. Mission teams scrambled to slot observations into tight schedules. The Mars Reconnaissance Orbiter, with its powerful cameras, may capture images no one thought possible. A direct look at an interstellar body passing near another planet. Opportunities like this are once-in-a-century alignments, and scientists are eager not to waste them. 3 weeks later, from October 21 to 23, 3I Atlas enters superior conjunction. From Earth's point of view, it passes almost directly behind the Sun. To ground-based telescopes, it vanishes into glare. But to spacecraft like SOHO and Stereo, which monitor the Sun continuously, this is a front-row seat. If the comet's tail is torn, twisted, or brightened by solar storms, their coronagraphs may catch it in real time, images posted to public servers within hours. It will be a rare moment when professionals and amateurs alike are watching the same drama unfold nearly live. Finally, at the end of the month, October 29th and 30 mark perihelion, the closest approach to the Sun. At the very peak of solar activity, when sunspots and flares are most common, the comet will dive directly into turbulence. Its natural processes. Remarkable, beautiful, but natural. Still, that does not make it less profound. Suzanne Faltzner and others studying planet formation suggest that objects like this may be the seeds of worlds. Not intentionally, but statistically, wandering fragments from other stars, scattering carbon, oxygen, and ices across galaxies, sometimes colliding with young disks and contributing the ingredients of habitability. Perhaps Earth's own chemistry was enriched by such visitors long before life began. In that sense, 3I Atlas is not just a curiosity, but a messenger of possibilities. The global scientific community is preparing in unison. SOHO and Stereo will monitor its passage near the Sun almost non-stop. Mars orbiters will glance sideways as it swings past their planet. Ground-based observatories will track brightness surges, outbursts, and spectral fingerprints. Amateur astronomers, too, will have a role. The Comet Observers Database, COBS, invites them to submit light curves, sketches, and tail measurements. The SkyLive provides finder charts and community logs. Even citizen science projects on Zooniverse are ready to crowdsource classifications of changing features. For 3I Atlas, the front row is not reserved for professionals. Anyone with a telescope or even just curiosity